Okay. So area of rectangular strip. Or another way to say it is a little bit of area. And what does this integral sign stand for? So it still stands for sum. And so when we sum up all the little bits of area, we get total area. So it makes sense, right? Total area. Total area. When you sum up little bits of change, you get a total amount of change. When you sum up little bits of area, you get a total area. And in calculating a little bit of change, the dy, the dx is part of that calculation. When calculating the little area, the little bit of area, the dx is part of it, right? It's one dimension of your strip. It's the thin dimension of your strip is the dx. Okay. And so then you can predict. So where we're going next is we're going to look at volumes. Volumes. So tell the person next to you what's going to be the meaning of what we take the integral of, and what are we going to get? Tell the person next to you. Go. It's the same thing again. Okay, so I want to just confident. So how many people said that? How many people said that? Should be all of you. Okay, it's the same thing again. Now, the way we get a little bit of volume is a little bit of volume can be different things. Okay, but the solids that we're going to be finding the total volume of are going to be found by, or when we start with, is ones where we're going to take a region, like we did with these areas, and then we're going to take that region and we're going to revolve it around something. When you revolve a region around something, you get a solid, and so that's what we're going to start with. Okay? So let's look at our first example here. Are we good on this page? So we want to find the volume of the solid formed by rotating r around the x-axis, and r is the region formed by y equals 0, y equals x squared, and x equals 8. Okay, this should be an easy region to sketch first, so let's do that. Y equals x squared, piece of cake, x equals 8, something like that, and y equals 0. Okay, y equals 0. So y equals 0 is the x-axis. So first off, we're talking about, that's r. That's r. Okay, so I'm going to take r and imagine the x-axis is like a hinge, and that region is like a door, okay? And it's going to swing around the hinge of the x-axis, and everywhere it goes in space is going to form that solid. So it's going to sweep out the solid. So what are we going to get? What's that solid going to be like? So oftentimes, food is helpful to define these solids. What are you going to get?
Bagel.
Definitely not a bagel. So do you understand what we're doing here? If you thought it was a bagel, we're not in good shape. Okay. This is the hinge. And I'm just it's like a door, like a doggy door, okay? And so this right there, that region is going to swing around the hinge, and everywhere it goes in space is going to track out or sweep out this volume. Okay, so like a cone, yep. So do you see that when it gets 180 degrees, it's going to look like this? At 180 degrees, it will look like that. But then imagine it flipping all the way around. So do you see that you'll get something like that? Okay, if I'm looking at it just like this, I'm going to just see a disc, right? I'm just going to see a circle. Then it's going to be like that. So it's like a Hershey's Kiss on its side. It's like a Hershey's Kiss, like tilted up on its side. So how are we going to do this? So the way we're going to do this is we're going to go back to our typical strip, and the little bit of volume that we're going to calculate is based on if we took the rectangular strip and did the same rotation on the rectangular strip, what are we going to get if we do that? So let's draw the strip. Okay, so there's our typical strip. Now I'm going to just take that strip and rotate it the same way. What will I get from that? What will I get when I take the strip and revolve it the same way I revolve the whole region? What's that going to form? Right. You're going to get a pancake. It's all about food. A pancake or a disc. Okay? It's getting worse. All right, so what did we say? To get the volume of the solid, we're going to sum up a bunch of little volumes, right? A bunch of little bits of volume. And so each bit of volume is going to be a pancake. So here's like in our solid here. There's a typical pancake. And we're going to have all the typical pancakes starting at the point there on the left, moving from left to right, and then the last one will be the base of the Hershey's Kiss. Will be that biggest pancake. Okay? So what we want the volume of a typical pancake. So what shape is that? What's the formula for the volume of that? What really is that? It's just a circular cylinder, right? Pi r squared h. Okay, so what's the radius? The radius of this thing, we have to go back to our region, and we need to know what is the radius of our pancake. So we come back here. What is the radius? It's this. It's basically the height of our strip in this case. So what is that dimension right there? It's just y, right? It's just a y coordinate. And what is h? H is the little thickness of the pancake. So what is h? So go back to this. So h would be this right here. Delta x. Again, now since we're doing delta x, we need y in terms of x. So we need the y coordinate of that in terms of x. X squared, right? So that the radius of the pancake is determined by that curve right there, the y coordinate, and the y coordinate is x squared. So it's going to be x squared squared. So that's any typical pancake, vertical pancake here, has a volume of pi x squared delta x. And what are we going to do to get the total then volume of the region? So this is our setup work. Put it in a box. So now the volume of the solid equals the sum of all our pancakes, right? Will be pi, and they're going to, as they get very, very thin, right? Okay, and that's going to be from the first little element is at x equals. The last element is at 8. Done. Again, easy integral. You can do that in your sleep. The value that you get now, so when you finish that and get a number, the number will be the volume of the Hershey's Kiss that came from taking that region R and rotating around the x-axis. Questions on that first example? Okay. Same region, but instead of rotating it about y equals 0, the x-axis, I want to rotate it about x equals 8. I want to get the flavor for this because what is this y coordinate right here? Yeah, so compared to, so if this is 8, you got to imagine that how much are we going up? 64 units, okay? So this is a lot, so this is not to scale. That region, if we had an even scale on x and y, would be really tall and skinny, okay? It'd be super tall. It could be 8 times taller than it is wide. So I'm just trying to at least show that a little bit here. I can't show that exactly. But so now we want to rotate that thing about x equals 8. So same region. And we're going to rotate it about x equals 8. What will we get?
Similar to what we got before, except it's going to be longer.
Yeah, so similar. So the one we would have gotten before would have been would have a really big base, really big circular base, and be kind of stout this way. This one's going to be really tall to the point. Okay, so it's going to be a different volume because it's a totally different shape. But anyway, when it hits 180 degrees, it's going to look like this. And so then the whole thing is going to look like this. When we're all said and done, we're going to get a similar shape, but a different version of it, right? Really tall and narrow from the base to the tip, to the point. Okay, so how are if we're rotating about x equals 8, then this time our strip will be a delta y strip. And when we rotate about x equals 8, we're going to get a horizontal. We're going to get horizontal pancakes. So we're going to take our typical strip. When we rotate it around x equals 8, we're going to get a typical pancake that's stacked up the way pancakes normally are, right? So volume of the pancake is still a cylinder, pi r squared h. So now we've got to figure out what is this. This is the radius. This is if. Let's see. So down here. So we need the radius of the pancake, which is going to be what? From here to here. It's going to be our radius. So you got practice with this with your rectangle, your typical strips. What is that distance r that I'm showing there, which will be the radius of the typical pancake? Okay, so this is going to be the difference of x or y coordinates. It's going to be a difference of x coordinates. It's a change in x, right? It's a change in x from the left side to the right side. So to get a change in x, to get that horizontal change or distance, it's going to be final minus initial, which would be what? 8 minus x. Do you see that? R is going to be 8 final x minus initial x to get that change in x. So the radius is going to be 8 minus x. Why? Because this distance is 8. This distance is the x-coordinate. The x-coordinate starts at the y-axis and goes to the right, right? That's your x-coordinate. Out to the center of rotation is the center of the pancake is 8. So 8 minus x is going to be that radius. What is our, so the height now is then this dimension, which is what? Delta y, right? Just like the strip. So it's the little narrow dimension of the strip would be delta y. So here's our, but if it's delta y, then we got to get x in terms of y. What is x in terms of y? Square root of y, okay? So if y is x squared, then x is square root of y. So we have 8 minus square root of y, quantity squared. Got our setup.
How come you don't do plus or minus square root of y?
Okay, how come? Because we're talking about what is, so yes, x is the square root of y, and then x is, what is x equals the negative the square root of y? How does that graph? What's the graph of that? It's this over here. This is x equals negative square root of y.
So if we did plus or minus, we would get 2 instead of just 1.
Yeah, I mean you need, yeah, you'd have the wrong, if you do, you can't do both. You can't do plus or minus in a calculation. It would be 2 different numbers. So one of them is right and one of them is wrong. So we want the x coordinate of x equals positive square root of y. X equals negative square root of y is this curve over here. It doesn't have to do with what we're doing. See that? Okay, so then we are ready to write the integral for the total solid. Integral from, so we're going to go from left to right or bottom to top? So we think about, so since these pancakes are horizontal, the first pancake is the one on the bottom. So what value do we start at?
0.
0. So we imagine this first pancake down here at the bottom, that's at y equals 0 down here. So we're starting at 0. And then we're going to add up all the pancakes starting at 0 all the way to, which is the very last one?
64.
64, the y value right there. mostly easy, right? It's still easy. Just multiply it out, and you've got 3 terms. Take the antiderivative. Okay, so at 10 o'clock, the web work for Wednesday will be open, and you can get started on it. But we'll finish that up Monday and go on from there. Okay.
So I just didn't like see how like when this rotate the little strip, like how does it get to like this, you know? This
No, it's not that. It's the pancake. You know what a pancake is?
Yeah, yeah.
It's the whole pancake, right? So imagine if I took this and rotated it around. You get a pancake with a little bit of thickness, right?
Yeah.
Yeah.
So what's that little strip? It's just like that part, like you know.
No, I'm drawing. Oh, I'm just drawing. Sorry, maybe I shouldn't have shaded it. So here I didn't shade it. Does that help? It's just a solid. It's just a pancake.
Okay,
So maybe I shouldn't have shaded. That's just the edge. I just shaded the edge.
Oh, okay. So
Just to highlight the edge.
our really does nothing besides finding them.
What?
So our like this strip doesn't do anything to tell us besides just helping us to find the radius.
No, that's when you rotate that strip around the x-axis, you get that solid.
Okay.
You take here's a strip, right?
Yeah.
I rotate it around the x-axis.
Oh, okay.
You get a pancake, and then I was drawing the whole pancake that you got if you rotated that strip around the x-axis.
Oh, okay.
So does this make it easier to see? Like now we're doing it horizontally, right? So if I take that strip and go around like that,
Okay. Okay.
I'm gonna get that shape right there. You buy that?
Yeah. Got it.
Do you?
Yeah.
Okay. Yeah, you can ask in the lecture because maybe someone else has the same question. Don't be afraid to ask. Yeah.
Hi, I just have a quick question. So, right here, when we're setting up the radius,
Yeah.
why wouldn't this be x squared? Because isn't that the distance?
No, it's just the x coordinate, right? So distance from we want that distance right there, right?
Right.
Do you agree that that's this distance
Minus that distance.
minus this distance? Well,
But
that
that's-
distance is not x squared. It's just x. That's the x coordinate. The x coordinate is how far you go from the y-axis, right? Like
Oh, because the distance from.
Right,
Okay,
so-
never mind, I got it.
see x y.
Yeah.
What is this distance right there? What's that distance?
X.
X. That's just the x coordinate.
Okay, so if we were taking like this distance, that would be x squared, right?
If you needed to write, yes,
Okay.
right, because this is y, and if you needed to write that in terms of
Right.
x, it'd be x squared.
Okay.
Yes.
Thank you.
Yeah. Ask me what.
tried to.
Oh,
I
are you,
had my hand up.
oh, then just say something fast.
Okay.
Yeah, sorry.
My grade for the test is I don't have a multiple choice grade put in love work. Just the blank. And so my raw score is like really, really low.
Oh yeah, you should have both. Did you take it with everybody else?
Yeah.
Okay, let's see. Oh, it's because you didn't put your name. You didn't bubble in your name. You were the culprit. You didn't bubble in your last name. You just bubbled in your ID number.
Oh.
So I'll find that. So
Okay.
what is your name?
Karen. Karen Victor.
Victor?
Yeah.
Okay, Victor. I will fix that.
Thank you.
Okay.
I saw my low score and I was like, what?
Sorry.
Really?
Sorry. No. Yeah. So I was gonna go look up your ID and figure out who you were, but I forgot to do that. So make sure you bubble in your last name.
And when it comes to like grading like the quizzes that we took, do we get partial credit? Because I
Yeah.
realized like after we did like the
Yeah, it's not all or nothing.
like I switched my equation, so I did instead of doing 6 minus x, I did x minus 6, and so then my line was wrong, and I was like, no, that means if I messed up this one, I messed up the other one, which means I got
right.
like
In this region.
Yeah. I'll hopefully you get something.
okay.
Yeah.
Thank
Yeah.
you.
Okay.
Determined via
Hi.
y
Good.
value minus y
I had the same question actually with
But
with
equation that
so I
determines
kind of got
how
stuck
y value
on
to this
finding
point
from where it's gonna go. Does that mean we're gonna get it all
So
more?
when you cross over
It
this
depends.
side,
I don't know. Like
different equation
uh,
determining the top y value.
you got so like you didn't have the region right.
So you could
I
just write
didn't
it
know from
as
where it was
1
gonna
to
go,
the
like
strip
from 0
applies
to
to
2
the
or
whole
from
region.
5 to 2. I had the integral. I mean,
Oh no, that's perfect. I mean, if you have the right region and you do some work that's like you set up the right strip like area.
yeah, like how
Yeah.
you did it. Okay.
Yeah.
And so if you put if I want to graph an x equal y thing, So how like do I change the y, the x with the y?
X equals y.
For example, x equal.
Yeah. So the two examples I've shown so far would be like switch x's and y's and sketch it in how you're used to it.
Y, and then just
use reasoning to say like, oh, this is a parabola. It's opening up on this axis. So if I switched x and y, it would open up on this axis.
Okay. Yeah, except that.
And if it has these points, and I switch x and y, now it's going to have the points with those coordinates switch.
The problem is the roots. I didn't know how to find the roots. I forgot about this, so I did it on the same way you did it, except on x equal +1 instead of -1. So,
Okay.
Do we get at least partial credit for that?
Yeah.
Probably.
Yeah, I guess so.
Okay.